Okay, welcome everybody to another session of AI and the Enterprise. Glad to see everybody. We're going to get started. Just a couple announcements as usual. Again, this is a monthly webinar that we get to do with very special guests from industry. We're bringing their experience, particularly in how artificial intelligence is going to be impacting different enterprise strategies and operations. Before I get started with Dr. Anand Rao, today, I just want to again encourage everybody to use the chat to ask any questions. This will be fairly interactive. We'll have some sections as we go where we'll be able to ask Dr. Rao some questions about some of the things he's presenting and also his experience as well. He comes with about 35 years of experience in this realm. Again, Dr. Anand Rao is the Global Artificial Intelligence Lead and Innovation Lead with PwC in their Emerging Tech Division. He has his PhD from the University of Sydney and an MBA from Melbourne Business School as well. And today we're going to really keen in and focus on how we think about return on investment when it comes to opportunities. This is a question that we get very frequently on this webinar, and then also, again, just in practice as we engage with one another. This is a kind of a scenario where we think about trade-offs and we think about different opportunities and which ones are the right ones to tackle. So we want to be able to get to some insights on that. So we're very thankful to have Dr. Anand Rao here. With that said, I'm going to turn it over to him, and please take it away.
Thank you very much, Jin. So thanks for having me, and great to be here. As Jin was saying, my background is very much a mixed background. So I spent around 13, 14 years in AI building systems for NASA, DARPA, and the Australian Defence Organization. So very much on the technology build research side. Then shifted, and as many of you know, there are multiple AI winters. One of those AI winters, I deserted AI, went into management consulting. So did my MBA and went into management consulting, more on the strategy side for almost a decade, both in London and in US. And around about 2007-8, as the next wave of AI started picking up, I was probably at the right place at the right time, and then started doing more of data analytics, AI, big data, all of that within PwC. I came from a company that was acquired by PwC in 2010, so obviously with PwC we were able to expand. So what I wanted to do today is specifically address the issue around return on investment, ROI, from AI, based on what we are seeing, some of the surveys that we have done, as well as other people are working on these areas. So basically, to give you a quick overview around AI adoption and specifically around the issues around ROI, what are some of the challenges with ROI, specifically for AI? And I think the key thing I want to leave you with is that often people tend to equate AI with software development and software projects and try and basically put the same kind of ROI lens on how they evaluate projects. And that is fundamentally flawed. And I'll argue that case and see what are some of the remedies. Also look at what are some of the adoption issues and where and how we can get a better ROI in AI as section 4. And if time permits, maybe do a quick couple of case studies in various areas of AI, strategic and operational. I'll break at a couple of points here after number 2 and after number 4, so you'll have an opportunity to intervene and ask some questions. So with that, let me just dive into AI adoption and ROI. Again, I'm not trying to define AI, analytics, and so on, so we can get into all of that. So however broadly you define AI as automation, plus also informing better decision-making, so to take that whole thing as AI, that includes machine learning, deep learning, a number of other areas. I'm not trying to define here, so that's something that I do often, but here I just wanted to focus on what is this broad notion of adoption. again, we do a number of these surveys, as I mentioned, and one of the surveys that we did in late 2020 just shows the adoption of AI definitely picking up, and the pandemic was actually good for AI in the sense that more people were exploring some of these areas. Again, 79% of business leaders have either promising proof of concepts or fully enabled AI across their enterprise or across business units, but our data was showing fewer than 24% are really seeing a positive return. Rather, 76% said that they are just barely meeting their investment, sort of coming back to break even. So 24% are not seeing a positive return yet. I also pulled out one of MIT Sloan's recent report on, again, expanding AI's impact. They had a very similar thing. So they said only 1 in 10 companies, or 11% to be exact from their report, exhibit significant financial benefit. I don't think they quantify that significant, but at least this is from the company saying that only 11% are seeing significant impact. So yes, there is an issue around ROI and how we think about ROI for AI. Now, we can go into, there are a number of reasons, so I want to highlight 2 of those. And one of them here is model deployment. A number of companies, according to our research, roughly 75 to 80% of the companies are still in a POC, proof of concept stage. And many of the companies that have deployed, the 20-25% that have deployed models at industry scale in their environment, have tended to do better. So less than 50% of the best models are really deployed, and greater than 18% of those models take more than 90 days. It's slightly older. It's an April 2019 report by IDC, but I think some of those numbers might have gotten better, but that's one of the big issues. Again, a great article by Tom Davenport around, once again, what are some of the challenges? And you can see here people talking about either good intentions, but we are not really putting products, models into production environment. And that's a big challenge. Again, number of reasons for that challenge, but again, deploying models in a production environment, in a transactional environment, 24/7, working with other software systems and data systems is one of the challenges and is key for getting better ROI. The other issue that crops up quite often is this whole notion around ethical and AI risks. And again, 84% of business leaders think that AI-based decisions need to be explainable, but only 40% of them fully tackle some of these risks. Again, I'm sure you have seen a number of articles, again, not picking any specific company here. So every company somehow tripped on this issue around bias and fairness, as this particular example shows. It's also the safety as it relates to driverless cars. And of course, quite a lot of deep fakes that are going on, right? So there are a number of these risks of AI, and that's also been a hindrance for people actually going into production. And as a result of going into production, they can get better ROI, but there are also all these risks. So trying to manage these risks also tend to be something that that folks are finding that they need to do. So with that, that's just a quick overview. So now let's get into the notion of ROI. And as it relates to ROI, what I wanted to do is to just sort of highlight a couple of things, and then we'll dig into a little bit deeper in the next section. So the primary question is, what is ROI in AI, right? So again, it's return on investment. So what return are we looking at, and what is the investment? We need to dig deeper here. So what is AI doing? So typically, as I said, it's either an automation, which arguably may or may not be AI, but some people would consider that as sort of under the broad AI bucket. So what are some of the value or benefits coming from an automation? And on the other side, it's more better decision making, better recommendations, better predictions using AI. So we are now trying to look at what are those benefits and how do those benefits stack up against some of the costs or investments that are needed to produce those AI models. Again, very classic definition, nothing new here. What complicates it further is, in addition to what is a prediction and how do we count those predictions and what is the value of those predictions, is this probabilistic nature of outcomes. So when you deploy a software system, the software system just works 100% of the time. Whereas when you look at machine learning models, people say, oh, the accuracy is only 93% or 86%. Now, the question is, what happens during the other 7% or 14% of the time? How do you account for those quote unquote errors? And who is looking at those errors? What are the cost of those errors, right? So those things sort of complicate it further because you're looking at something, a result that is probabilistic or uncertain, as opposed to a software. Once you have tested it, you put it, deploy it, it should work, right? So, and it'll work. Otherwise, there is a problem with the software, you'll go debug it and come back. So, but AI works somewhat differently, and that's something that we'll come back to. Then, of course, comes the quantifying problem, right? So you understand what return and investments are with respect to the various components, but how do you really quantify? Now, AI, especially the decision-making arena, is something that is, it makes a decision. And when you say 93% accurate against what benchmark? It's typically a human benchmark, i.e. it is doing 93% as good as a human. Then the question is, which human? Is it the best expert underwriter in your insurance company? Is it an average underwriter, or is it an entry-level underwriter? So what is the benchmark that you're trying to baseline? And even if you baseline it, the challenge which our clients run into is no one has actually gone and measured it in any meaningful way. And it usually happens in terms of samples, the data sample that you have, and someone goes and does it. A human goes and does it. One or more humans will do it. And that's your set. So you are comparing it against a benchmark of a created data set and labeled data set. So that becomes a big issue. There are a number of other issues in terms of soft benefits, soft investments, which are there for others, but are probably more pronounced for AI. So on the one hand, the reason why we are looking at ROI is there is an inherent challenge because it's AI as to both try to understand what the return and investments mean in the AI context, and then also how do we start quantifying at least some of the hard benefits, then we can get on to some of the softer benefits. And so what are some of the opportunities to create and sustain value? So I added sustain value mainly because there is an issue with AI and machine learning models specifically, that their performance can deteriorate over time because it is a much more dynamic setting in which these models are learning on a daily basis, minute by minute basis. Those can start deviating. So you might have a good value initially, but that value could deteriorate. So you need to really sustain that value. So that leads us to a couple of things here. We may not go into a whole lot of detail. We have spent quite some time in each one of these areas. So one is deployment of models. As I said, how do you deploy models and get more value? Again, very much from a production environment, and hooking it up with all the other systems and data is where you get the value. The next one is more around agile AI. So often AI gets lumped with software, as I mentioned. Data science gets lumped up with software, and then software development has gone very much that agile cycle. Throwing in data science there, I think, could be quite counterproductive. You really need to do what we call as interleaved agile, which I'll come to in a minute. And then lastly is the responsible AI, understanding the risks and embedding some of those right design principles right from the start, as opposed to doing it at the end. So those are some of the challenges and also the opportunities in which we can increase the ROI from AI initiatives. So what I'm going to do here is maybe take a quick pause here and see if there are any questions before I dive into the meat of what is different between data scientists and software developers.
Great, thanks, Anand. A couple questions here. Should ethical constraints be added to the ROI cost of errors? not so much monetary, but in terms of human decision-making factors.
Yes, very much so, I would say. And what has been happening in the entire area of AI ethics, I think next to deep learning, AI ethics is probably the one that has received the maximum attention. Of course, deep learning is number one, but after that, it is AI ethics. And there are a number of documents that have come out, including a recent one by EU. And what they definitely say is when you look at deploying or even starting AI projects, you need to go through a certain risk assessment and a harms assessment, right? So what are the different safety issues and ethical issues that could happen or what could go wrong right up front, so that you're moving very consciously into should this be done and in what ways you mitigate. So I would say, yes, whether you are able to take into account in a quantitative manner or not, but definitely on a qualitative manner, you should look at the context in which this AI is going to be used and what are some of the risks, and specifically reputational risks, right? So again, we have seen all the issues around bias and fairness. So if this is a very sensitive area like HR or image recognition and so on, we need to be careful and saying what is the overall value versus the potential reputational risk and how are we mitigating it. If we don't do that, we could go quite a way in and then discover that, oh, we really don't want to deploy this because this is very it's a hot potato issue, right? So let's just back off. You're better off backing off right at the scoping phase as opposed to going all the way and then someone at the business level saying, hey, hang on a minute, we don't want to do this. So I would definitely agree that you should include it in the early assessment phase.
Yeah. To borrow an analogy from doctors, there's this whole do no harm, right, ethos that you want to have.
That's right.
As you start doing the assessment before you build the tool. Because once we get into there's this financial return on investment that makes decisions really difficult for companies because you have the potential to maximize and capitalize on this, but the ethics decisions really need to come way in advance, and you should be having those discussions. Okay, a couple other ones here. How often are error signals for new research directions?
Often are errors signals for new research directions? Very good question. I would say, I think errors are typically when you're exploring something new, the errors point you in a different direction, right? So leading to a better research direction or something where you need to enhance the model. Where I think where it is an error as opposed to needing more research is when you have done this repeatedly, right? So then you have a good understanding of the domain, of the data, of the techniques and all of that. So then I think you get a reasonable level of comfort. So what we have seen is, I'll just take an example. If you're doing, we do quite a lot of natural language processing on unstructured text, which could be regulatory documents, it could be legal documents and so on, right? So early days, we were not sure whether some of those results were right or which direction we want to go. So now we have been on this for almost 6 years and we process a huge amount. I mean, as PwC being an audit firm, we process huge amounts of this sort of unstructured text. So now we are reasonably confident that when we look at some of these results, we can say what it is, where it is. Of course, we are constantly improving the algorithms based on whatever is happening in the external world, but we know that, hey, this is not just an error. So this is the best we can do, right? So this new area is not going to enlighten us more.
Great. Another question here and this is more just your thoughts. This person was asking, they're not quite sure about agile development being suited to data science and machine learning work, maybe once after the value pop is prototype. So your thoughts are sort of—
I'll come back to that. I'll come back to that. I definitely agree. And that's what we are proposing as a sort of an interlead agile. I think once I do that part, it should become clearer.
Okay. And then how do you incorporate sample customers' resource time, inclusive in designing AI solutions and to have ROI calculations before scaling it for other customers?
Yeah, that's right. So one of the things that you'll see as we come later, I think we really need a proper methodology for scoping the project, how you're doing the discovery of the various techniques. So as we do that, I think we should be very conscious around how are we going to test it and who is going to say A or nay for this, right? So at the business level, at the subject matter expert level, and what is the cost of bringing some of these subject matter experts into the project? And again, most of the time, people are just looking at, hey, how many data scientists do you need? Okay, is 4 enough, right? So how long are you guys going to take? What they don't budget for is all of these experts who are maybe underwriting expert or might be a manufacturing expert, supply chain expert. So we don't account for those, but they are the critical resource. Otherwise, the data scientists, I mean, they're good with what they're doing. They don't have that domain information to verify or lead them in the right track. And that's something that we have started emphasizing more and more, right? So if you don't give that, let's not start the project. Wait till your people are available, and that's better rather than we starting the project and waiting or doing it in a way without involving your SIMIs, and it's not good for you. You will finish the project, but you're not going to deploy it if the subject matter experts and the operational people are not involved, right? So it sort of very much becomes that sort of bringing in the buy-in with them.
Great. Okay, let's move on to your next section. I think it's a good time, and then we'll address these questions again.
Yeah, definitely. Yeah, let me just go back to sharing my screen. Okay, so the fundamental problem, I think, sort of stemming from some of these issues is the notion of data scientists and software developers, right? So, and I think we often conflate the two or just say, oh, data science is just a special type of software development. At the end of the day, all the data scientists are also programming in Python or R using all these systems. So it's no different. They are on the cloud platform like everyone else. All of those sort of tend to equate data scientists with software developers, and this is probably seen more with the CIOs and the technology side of it. In fact, I wrote a blog around, but they could be so much apart in terms of their thinking, right? So we'll come to that in a minute. So there's a blog around data scientists are from Mars and software developers are from Venus. So what I really mean here is there are a number of differences between how software is developed. And when I say AI, let's get specific around machine learning models, right? So let's stay away from some of the rule-based systems just for this purpose, right? So it's just stay with machine learning models and how they are different. Everyone knows input plus an algorithm gives an output. And then, as I said, that output is sort of implemented, tested, and implemented, and you get some value from an automation or for some software. Whereas in ML, in machine learning, not only have the input data, but someone, again, this is one type of machine learning, i.e. supervised learning, where someone is labeling these as this is a fraud or this is not a fraud, right? So some kind of a classification, a human expert is labeling some of these transactions or potential fraud or not a fraud, a normal transaction. So that is the labeling. So you're basically taking some subset of the output and the input data, and the machine learning algorithm is essentially coming up with it, right? So ML model development is, hey, let's build something whereby that pattern of what is a fraud and what is not a fraud is detected by the machine using machine learning, right? So in other words, the algorithm is created to classify. In this particular case, it's a classification between a fraud and a not fraud. But that algorithm is generated, if you like, so that once you have trained the system, this is a sort of a training phase. So the first thing is to get lots and lots of examples of input data and specific output data that is labeled to the system, and the system gets trained. Or in other words, just like a child learns, the machine is learning what is fraud, what is not a fraud, based on individual instances. Once we are comfortable that there's been trained sufficiently, then we let it out into the wild, if you like. So use it in production otherwise. And once it gets into production, it's getting new instances. And now it's making a prediction as to whether it's a fraudulent transaction or not, right? So basically machine learning has two phases, training phase and an inference phase or a production phase. And it is very different to the way software is done. So that raises a number of issues. This very fundamental way in which software gets developed versus model gets developed exhibits itself in these 5 areas, right? So I'm just sort of contrasting them here. The software, the output is certain, right? So 1 plus 1 is equal to 2, right? So if there is a line in your C++ Java code, the answer is 2, 100% of the time. It's not that 98% of the time it's 2 and 2% of the time it may be 1.99. No, if it's 2, it is 2, right? It's certain. Machine learning models, as we know, are not like that because it's taking a whole host of data. And if you fit it perfectly, then it doesn't perform well when it goes to inference because you're basically programmed for exactly the cases that you have, right? So you wanted something generalizable. And that's why it is uncertain or it's probabilistic. There's one issue. So the second issue is the decision space, as we are saying, is static. What we mean by that is when you have a software system deployed, it is interacting in a same way day in and day out, right? So if there are no changes made to it, it's working exactly the same way. Whereas machine learning models, the data might be changing, right? So every day the world is changing, consumer behaviors might be changing. If that's sort of feeding into your model, then the decisions we are making is changing from what it was. So for example, so we're working, a large telco came to us because they had deployed a lot of chatbots, which were very well trained, and they were, I think, 96% accurate. Only 4% of the calls were going to the customer service rep. As of, let's say, December, they had trained the model. Now, when they implemented it in January, their performance was good. In February, it deteriorated a little bit. March, it deteriorated even further. In 6 months' time, it was at 65% accuracy. In other words, 35% of the calls were going to a human agent as opposed to only 4%. They said, we just trained everything properly. What happened? Now, the problem is the new devices were coming, right? So iPhone comes up, iPhone X is not there in the database. If it is a human operator, they just go, oh yeah, iPhone X, I know it just got released last week, and let me look at apple.com, and they'll go handle the query, and they'll file a request that there is a system is incomplete, right? Whereas the poor chatbot doesn't know that. It doesn't understand iPhone X or versus iPhone 11 or iPhone 8, right? So it doesn't understand that. So the dynamic space in which the decisions are being made is continuously changing. So the model needs to be updated based on new information. In some cases, it may be daily, monthly, weekly, whatever the frequency. The inference, that's sort of the second part. The inference is more deduction as opposed to machine learning models induction, so giving multiple examples. And I think this is what one of the questions was, is agile really even applicable, right? So software is very much iterative, right? So no doubt iterative, but it is linear and iterative, whereas in ML models, it's test and learn. So how do you get test and learn going within an agile environment? The mindset is very different too, right? So software is sort of software engineers, right? So they want everything specified to a great level of detail, and then they just go build it, right? So you can scope problems because you have a scoping, and then number of people are involved. Again, there is uncertainty around what exactly you're building, but it is more an engineering discipline. Whereas machine learning, in its sort of truest sense, is truly a science, right? So it's a data science, and people are experimenting and learning, right? So most of the time, of course, now we are getting to a stage where some of it is moving into engineering, but there is still a big element of science in it, in its true form, that I don't know what answer I'm going to get. I'm going to try different algorithms, different massaging of the data, maybe even getting additional data from external sources, and try to get to some insight, right? So there's that exploration, test and learn. So all of those things are major differences, right? Again, I'll quickly walk through this. So again, in terms of the output, again, you're having a lot of these images fed, and the system is making a determination as to whether your image has a cat or not, right? So unless you train it on a huge number of cat images, along with a few other gorilla and flower images thrown in, it's not going to recognize the notion of a cat, right? So it can't arbitrarily come and say, oh, I can see one gorilla here in my 10,000 images, because it doesn't know what it means by a gorilla, or what we mean by a gorilla, or what we mean by flowers. It's essentially just doing pattern matching, takes up the image, sort of splits it into whatever number of pixels, right? So for each pixel, and then walks through that in various ways to try and find patterns. And that patterns is what it helps it decide, hey, it's a tabby cat, and it is, I'm 45% confident that it's a tabby cat versus an Egyptian cat, right? So that's based on all the things that you have fed. So that's why the labeling and having large volumes of data is important. Again, I'm taking a very specific case here in terms of deep learning. There are other methods, but they usually end up with this notion of probabilistic reasoning. So decision space, as I said, so this is a diagram from prediction machines, where if you look at it, so there's a human judgment involved. The input comes in, there is a prediction made by the machine. So the input is being trained and a prediction being made by the machine. And the human usually has some kind of a overriding authority in many cases, wherever there is a human in the loop and an action is taken. Right. So this part of it is very traditional. A software behaves the same way. Someone writes a spec, builds a model, someone tests it, and then they go and use it. But what is critical is this outcome. So the second feedback here. So once we get an outcome, we predict something to be a fraud, and there's an opportunity now for someone looking at it, and the human operator looking at it and say, no, that's not a fraud. That's a rare transaction, but it is not a fraudulent transaction. So that new information needs to go back into our training so that that model is continuously being updated. So this feedback process is what makes the decision space dynamic, right? So either our model is not perfect, so we have to constantly keep updating the model. Even if our model is perfect, things happen where customers' behaviors change over time. So what was true 2 years back may not be true today as it relates to a particular customer preference. So in that sense, the world is changing. So we need to be cognizant of that. So that's the decision space. And inference, again, not wanting to go into the theory of this. So deduction is sort of basically you come up with a specification and then you build the code and that produces the output, right? So fairly logical fashion starting from the specification. Whereas in machine learning on the right-hand side, it's very much what is called as inductive logic, right? So there's an observation. In other words, there's lots and lots of data, and then you are looking at the data, and then you're creating a model that reflects the data. The model, by its very definition, may not match exactly what is there in the world. It is, as it says, it's a model of the world, hopefully capturing the right elements. So again, back to the earlier question, how do you know when something is an error or whether you need to actually expand your model? That happens quite a lot, right? So you think this level of parameters is enough to explain the data, but you might discover that you need to account for more information because you're not able to push the accuracy anything beyond the data that you have collected, right? So, and that is the iterative process. So you have built a model as much as possible, a simple model, train it and see whether it matches the new data. So there are ways in which you take away certain validation set and data set, test data set, so that you can keep validating this. So this process goes on, and that's what makes it very iterative. And you could go back and train, you could go back and model it, or you can go back and get more data. And in some cases, all of this will fail, and you'll say, we are not quite ready yet to develop a machine learning model. We should wait till we collect more data and collect more human labeling before we proceed. And we have told that to clients often, that we need to be collecting more data. Of course, we can help them build some of the tools to collect the data, but that's what happens. Again, I think we'll come back to the agile process. Again, as we just see, it's sort of we build iteratively, and it's a sort of a linear model, whereas in this, as I just went through, so the data model training can all happen, and it sort of happens in a test and learn environment. So some of the consequences of mistaking these models for software, again, written extensively about this, there's sort of 12 traps that we look at. I'm just going to pick just one key thing, right? So again, won't go into the details. There are lots of traps in terms of data, quality of data, the labeling of data, the bias of data, and so on. So there's a whole set of issues there. There's also issues around, as I said, benchmarking and looking at efficiency and effectiveness of decision making, both in estimating it and also when you're realizing it. So a lot of what I call as return traps, but there are also a lot of traps around scoping. Just have one slide which talks about the scoping, because that, I think, it's almost at the heart of, I would say, deflated expectations, right? So high expectations, but deflated output, I should say, from some of the AI models is because of this, some of these scoping traps, which people don't quite understand because it's very non-traditional from the software. So here is a graph. It's conceptual. Again, there's a lot of data that supports some of this in various blogs and various projects. So you're looking at model development duration on the x-axis. On the y-axis, you're looking at model accuracy. Obviously, everyone wants something close to 100, right? So something approaching human performance. Again, 100 here is human performance. Again, no one is to say that the human is right, but that's the sort of the assumption being made. Again, as I said, there are issues around which human or which class of humans. Is it everyone? Is it the experts? And so on, right? So there are all those issues there. But even assuming all of that, right? So you nominate half a dozen experts within the organization and you want to match their performance. Now you go back to the data science team and say, hey, just estimate the time it would take for me to build, let's say, a 60% accurate model. Now, it'll be extremely difficult for the team to come back and say, yeah, give me 2 months, I'll give you exactly 60% accurate model. They won't be able to. Nor would they be able to even say that we'll achieve 50%, 55%. I mean, of course, throwing up the coin and just making an arbitrary decision is at least worth 50%. But anything more than that, they won't be able to guarantee, and they won't be able to take the time as well, right? So, and they can't verify the data, right? So there's all these issues, which we call the pre-built scoping trap. So you go and ask the team, hey, tell me the number of months so that I can estimate the time and the cost it will take to produce this model. They'll sort of dance around this issue, but that's something that needs to be addressed fair and square. So that's one part. Now, yes, you make some promises. You say, okay, it'll take a month and a half or 2 months, whatever the number, 2.5 months, and we'll try and get it to as much accuracy as possible. Now you start training the model and you start seeing the curve, right? So just with the initial data and with some simple algorithms, maybe you are at, I don't know, 15% or 10% accuracy. And then you start putting more and more data and your accuracy starts improving. Now, the problem is at any point in time, you go to the team and ask, hey, what's your accuracy? You've got, I don't know, 35%, 40%. Can you improve it? How much more data you want? They'll say, yeah, more data is good. But they won't be able to really estimate whether this goes down or this goes up, right? So up to a certain point, right? So once you have exhausted all the data, and if the curve looks like it's sort of plateauing here and there's no way throwing more data just increases it marginally, the accuracy marginally, they're going to throw up their hand and say, hey, based on the requirements that you have, you're not going to cross 40%, right? So you make a decision as to whether it's a good enough model to deploy or not, right? So this is what we are calling the training trap, or a training scoping trap. Once it is trained, let's say you get to 55, 57%. Now, when you deploy the model, again, there is uncertainty, right? So one could argue, the data scientist could argue, hey, we add only limited data, so we achieved 57% accuracy. Now, why don't we deploy the model? And in deployment, we are going to get a lot of data. And of course, people are going to say, is this working properly or not? And if you have some feedback mechanism, we'll be able to use that data to improve the model further. And we might potentially go up to 70, 80, or even close to 90%, right? So this curve could go up. Or you can't guarantee that this curve could also go down, right? So that is the other uncertainty. So even after deployment, things can get better or worse. Now, let's say you have deployed the model, and the model could again, keep performing better and better as it sort of asymptotes to 95, 96%, or after your initial deployment, as I told the previous case with one of those clients, it could start dropping, right? So various things are changing. You're not completely changing the model, or you could start dropping, right? So this could happen. So again, this we are calling the model drift or the drift scoping trap. So you can't a priori, before you have launched the model, say my model drift is going to be X. You need a certain phase where you're monitoring the model. Then you can come back and say, yes, I think we tried the model for 3 months and the drift has been very nominal. So we are okay. As long as we come back every 6 months and monitor this model, we are okay, right? So they could give that, but they can't tell it at the start of the project. They can tell it at the different stages. So this makes the whole process very challenging to really estimate the ROI. So I want to just sort of close with this thing. So what is ROI and how to quantify ROI? So I think we need to look at the return parameters here and the investment parameters. There are hard factors and soft factors, right? So hard factors are time saving, returns are time saving, cost saving, productivity increase, revenue increase, resources, licenses, but again, within the constraints that I just mentioned. But then you also look at some of the softer things. And again, a resource for subject matter expertise. People often don't take into account the amount of time it takes to cleanse some of the data, label some of the data where people fall down. Sometimes they don't account for the compute and storage. So some of the training of these models, depending on the type of model, could take quite a bit of compute time. Yes, overall compute time has dropped, but you run a large deep learning model, and it could literally run for hours together even in a GPU environment. So we were building a COVID-19 model for looking at the disease progression, and it took 12 hours to run some of the big states. So we were going down to the county level and projecting the hospitalization. So it could take hours together, and that could churn up quite a bit of issues around the cost. So what I'm going to do is sort of 40 minutes here. Let me just present a couple of slides on the opportunities to enhance, and then maybe take a break here. So model deployment, when we talk about model deployment, so most of the time the models have been developed on a standalone model. So that's what was happening maybe 3 years back. Every group was just having their own data scientist group work on these models. Successful within that group, but it really didn't have a big ROI because not everyone was using it. You had to go and find that particular data scientist who had built a model, and then you can use their results, right? So it was not embedded. Then we went into the era of prediction as a service, and still a lot of companies are in this area where you take a model and wrap an API around it so that now other software could basically pull it, ask certain give it some data and get some answers out, get some predictions out, right? So that is fine. So as long as you're building a few dozens of models, you can still manage it, but it doesn't allow for continuous learning. It doesn't allow for all of the changes that are going through. And that's what we are targeting as a model factory, where there is a continuous improvement of some of these models, right? So that is the sort of the way in which deployment is going. The more, the larger companies and the ones who have better ROI are basically doing this continuous improvement. And they have automated the process of deploying not just a few models, but literally hundreds of models. And some are approaching thousands of models. So that's where the real ROI comes in, because now it is sort of first-class citizens with other software, data, and so on. So that's what we need to do. I'm not going to go into this whole cycle. This is our model development life cycle. And I think the key things are scoping, right? So given all the challenges that we went through, so that's the scoping part. The value discovery is where someone is experimenting and continuously revising the model, right? So that happens here. Think of it like a science experiment, right? So it sort of very much happens here. So when you are in this phase, you don't know what the answer is, whether you even have a right answer or a satisfactory answer. But coming out of it in 5, you should have a good understanding is, yes, the model works. We can have a decent accuracy and so on, then you go into value delivery, deploy the model, and then if there is not a great deal of drift, you can say, yes, the model is operational. And then you still need to continue. As I said, the value could start deteriorating. You need to have ongoing monitoring of your models on a regular basis, at least on annual basis, and in some cases before. So this is sort of it looks linear, but this picture actually shows the iterative nature. So you do the value scoping, you iterate multiple cycles in this value discovery, right? So a single value discovery phase could be done even within a week, right? So just get enough data, use your simple regression model, see how much you are pushing, then start getting more data, more expansion, more algorithms, and see how much you can push. So all that happens here, so multiple iterations, and then you get into a sufficiently satisfactory result, then you go into this value delivery, right? So, and again, you can continuously keep changing it until you say that this is business as usual, and then you're looking at value stewardship, or just making sure that the model is not drifting. Again, I'm not going into the details of all the different types of people involved. You can see a various number of roles that are emerging. So that's all to do with model management. So that's in terms of model deployment. So what I'm going to do next is to just pick up the agile, right? So again, I'm trying to contrast agile software development with agile software 2.0 is what I'm calling, or AI development, right? It's agile AI. So if you look at this, this is sort of the standard manifesto that the Agile Council has adopted. So more interest in individual interactions, a working software, customer collaboration, responding to change. All of these are the right things to do for a software. But the problem is, if you're just aiming for a working software, and you're looking at individuals and interactions, is fine, but data science involves multidisciplinary teams, right? So yes, you want individuals and interactions, but you want teams, especially the subject matter experts need to be involved. It's not just a working software that you want, and we have seen this happen. People want a working software, and the data scientists are pushed to a 2-week agile cycle, and all that they can do in that 2-week cycle is get the data and maybe do some simple regression and simple descriptive analytics and give it back to you, right? So, and every time they are in this sort of 2-week cycles, and they just don't have the time to go gather the data, do a deep learning model, test it with others, that's just simply not there. So you don't get insightful actions, you just get slice and dicing of data, right? So, and yes, customer collaboration is important, but let the data do the talking, right? So the data and model exploration is as important to a data scientist as customer collaboration is to some of the agile. And again, it's not just responding to change. You want to be innovative and differentiated and disruptive with your AI solutions. If you're just going to be incrementally better, why use AI at all, right? So you're really aiming for something better. And that's the reason why we put this software 2.0 together. And again, based on the 2 agile cycles. So this is a sort of the normal agile cycle where there's a product backlog. People take the sprint planning, they do the sprint backlog, and that cycle goes on 1-2 weeks, and different companies have that, and then you get a finished work. So now what we are saying is, there needs to be, right at the scoping phase, the data scientists need to understand what is it that we are building, and then they need to keep doing this value discovery in parallel with your software sprints. And this goes back to the question. So that might take a couple of cycles, 2 cycles, 3 cycles, but once they have a cache of tested models, that's when you put them back into the sprint backlog. So there are still more things to be done with the model, in addition to all the software and data that goes with it, right? So that's when you put it back into the agile queue, and then go through the agile process, and it gets deployed. Now you're doing value delivery of the model within that agile cycle, where someone has sort of made the model production ready, and you continue on this cycle of value discovery, right? So you might go back into value discovery, but you're interleaving this traditional agile software development methodology, which goes from here to here, with what we just saw earlier, that you need to do the value discovery, then make sure that you have sufficient performance before you go in, right? So this is what we call as agile AI, or agile software 2.0. So with that, I think just one more slide on responsible AI. So we need to address a number of ethical issues and a number of issues around bias, fairness, privacy, and so on. I mean, given the time, I'm not going to go through into these details. So I may talk about this for an entire lecture. So I'm going to just skip some of these. So you bring in some of the governance around how people are going to look at it from an end-to-end perspective, from top of the house to the data scientist, and also from the end. So let me stop here. So we've just looked at model deployment, agile, and ethical AI, and how those three could enhance the ROI. So I'm going to stop here and see if there are any questions that I can take. I do have a couple of case studies which I can talk to.
Okay, this is great. I think, especially that last section, I think you really fleshed out the tension points that I think a lot of enterprises face, which is we want this for efficiency, right? And sometimes they're looking at the same data, they're looking at some of the processes, but efficiency is not the same as thinking about innovativeness. And there's a subculture that develop within these companies where some want to, use the data to be able to deliver products that are forward thinking and think about innovation, while others are like, no, but efficiency, we can track the ROI much more easily and define it. And there's this tension right now where with limited resources, how we think about it, but this agile framework is good. It's worked really well in software, and you kind of bringing it to the forefront, how we think about AI, I think contextualizes this much nicer. So that was very insightful. A couple questions that came in the meantime, and this is one I think we discuss a lot, but what's the amount of resources and the time that should be dedicated to investing in sort of the gathering phase as opposed to in the MVP stage, right? So how do we think about it? Because you mentioned that, look, 2 weeks isn't enough, but sometimes I think, especially as data scientists, they're not able to go back to their managers and say, look, I need more time, because then they're like, oh, well, you've had all the time in the world. But as you kind of stipulated, this is science, we're doing experimentation. So what's the appropriate time, you think, or maybe a use case on how you think about data?
No, that's a very good question. So again, I think some of these just happen through the practice of the data science team and the businesses. What we have evolved and sort of help our clients evolve as well is right at the start, because I think there is this mad crazy thing that, hey, we need an AI model. People don't ask, right? So do I have enough data? Is the AI model really useful here? They just want AI because that's the biggest thing since sliced bread now, right? So everyone wants AI. So one of the first things that we do is to try and ascertain whether we really want to build AI model, or is it more a traditional software fine with it, right? So, and in many cases, it may be okay to just build a good software system, right? So where you're giving various things to the user, and there's no real decision making behind, right? So that's something that we work closely with. We have another group which is sort of more around software development. So now I think you need to bring your software developers with your model developers together with the business, so that you can decide whether you want to go the model route or just a pure software route. Software is always involved, right? So, but you want to do that. At that point, I think you can do a 1, maybe 2-week phase where you're ascertaining whether there is the right level of data, whether there's right label data. And again, there should be a checkpoint at that time to say, yes, we think we have enough data to proceed further, not to necessarily give an answer that, yes, it'll be 60% accurate or 70% accurate, but to say it is enough to explore. And we often find at that stage gate, many things fall down. They say, a lot of companies say, oh, we have lots of data, take all of our transactional data. But then we ask, okay, if all of these billions of transactional data, do you have something which identifies fraudulent versus non-fraudulent? They say, no, not really. We just sort of go through and yes, I mean, the fraud department somewhere has collected some fraudulent data, but that's nowhere matched with this billions of transactions. So sorry, no, we can't do it, right? So yeah, we can do it, but now we need to go talk to the fraud department and see how we can connect those transactions with this. And then we can come back and tell you, yes, we have enough data, but we can't proceed with just what you have given. Typically, they are in different silos anyway, right? So this is operational group, that's a fraud group, and they probably haven't connected the data. So I think we can take a couple of steps to make sure that A, there is data, B, there is the right data, and then proceed. And I think we've seen that a 4-week exploratory cycle is good enough to get some initial indications. And I think the more you're working with your own data set, you get comfortable as to what is it that you can do or cannot do with that, right? So now we can go back and say, yeah, for these types of things, yes, give us another month, we can do this, or we can't do this, we need more data.
Okay, great. And another question here around confidence levels. Do you ever use confidence levels as a way to further refine the value created by an AI project? As of decisions with 95% confidence level, should you have more value as opposed to decisions with 60%?
Yes, we have used the confidence levels, right? So again, based on very much the algorithm and also the people and their confidence level, right? So we have used the confidence levels, and a little bit of this is also getting the people who are going to be testing and evaluating your models early on in the game. If you don't do that, and this has happened multiple times, where the system, if it's going to help someone, or in some cases even automate their task, if you don't involve them, it's always very easy for a human to find, let's say a model is 98% accurate, to find examples in that 2% and go and tell management, hey, this is all wrong. Look at this example. It is ridiculous that the model is doing this. Now, what no one asks is, hey, do all of my people get that 98% of the things right that this algorithm has got? No one goes back and asks that questions of humans as to say, hey, have you got 98% right? I know in the medical arena, some of them have gone back and said, hey, how do human doctors look at these, right? So how accurate are they? And I can tell you they're not very accurate compared to the model, right? So, but this is still the model as a bigger onus, which I fully understand, right? So that 2%, if there is a death in that 2%, that is not good, right? So as we all know, right? So I think that's the that's the danger.
And then time maybe here for one more question. What are some of the main leadership challenges in implementing the model to get the desired ROI? So some tensions, what do you see?
So great question. I know this is a class on innovation, and this is something that I keep emphasizing, maybe not all that successfully. There is somehow this view that it is data science, so there's nothing special about data science. You guys should just do production software, keep doing it. What I think many people are missing out on is the speed at which things are changing within AI, machine learning, deep learning. So the biggest challenge I have and our clients have is justifying some time for the data scientists to do exploration. Whether you call it innovation, I call it innovation/exploration. And that's the biggest challenge, right? So if you don't get your folks some time to explore new things, this is not like just going and reading fantastic journals, right? So, and understanding, oh, that's what AI means, again, through various journals, right? So that doesn't give you the hands-on experience. So the data scientists need to be continuously learning and exploring things. And that's where I think innovation is critical. So the group that we have split we haven't split the group, but we give 40% of time towards exploration and 60% of time towards client innovation, right? So again, don't want this to be a sort of a ivory tower research, but they want to explore, but then apply it in a client setting for 60% of the time. But they should be given that 40%, and even just trying to maintain that 40% and grab that 40% so that they can have that vibrant discussion and diving deeper. It's probably the biggest challenge, I think, Otherwise, we just sort of keep missing, and we are using old technology, and things have moved on. And that, I think, is sort of critical. Of course, there are other challenges in terms of getting the right resources when it comes to deployment and so on. But I would say once you have got all of that, this notion around exploring things, because it's such a fast changing area, I think is critical for our data scientists.
Great. Well, Anand, thank you. We're at our time boundary, unfortunately, but this has been terrific. Again, people can reach out to you on LinkedIn. I know you're always interested in having conversations as well. Thank you, everybody, for joining us this morning. Again, we'll do this again next month. We don't have the date set yet, but we'll get that out to you. And Anand, again, thank you very much for all your expertise, and this was very insightful.
And I can send the presentation to you, Jin, and feel free to circulate it. There are a couple of case studies, and the case studies go through a 2-year phase in which we have helped some of the clients, right? So it does take time. I know everyone wants immediate results, but there are good ROI to be had if you are patient and work through the system, and some of them have succeeded well. So I'll send that across.
Wonderful. Thank you very much. Bye, everybody.
Thank you.